This is a video for AQA Further Pure Mathematics. Vectors, section 5.1, the vector product. We've already met the idea of combining two vectors of product in the form of the scalar product. So A dot B, it's sometimes known as the dot product, A dot B, which produces a scalar. An alternative to this is to have what's called a vector product, and that uses a cross as a symbol, so A cross B, and hence is sometimes referred to as the cross product. And that's what we're going to define now. The reason it's called a vector product is that this produces a vector as an answer. So this is a vector, whereas the dot product is just a number, a scalar product. The vector product is defined by this quite complicated looking formula. However, you don't need to learn this. It's given to you in your formula sheets. And also, you notice it's actually quite symmetrical about it. If you look closely, the top line there is produced by the products of the second and third elements in the two vectors that you're multiplying together. So A2, B3 minus A3, B2. The second line is the product of the third and the first elements, A3, B1 minus A1 and B3. So you can see how this formula is made up. So here's an example of that in practice then. We've got the vector 1, 3, 2 cross product with 3, 4, 2. So the top line will be comes from the products of the second and third lines. So 3 multiplied by 2 minus 2 multiplied by 4. We then got line 3 multiplied by line 1. So 2 multiplied by 3 minus 1 multiplied by 2. And then finally, for the bottom line, we've got 1 multiplied by 4 minus 3 multiplied by 3. And if you calculate those, then it's 6 minus 8 minus 2. 6 minus 2 is 4, and then 4 minus 9 minus 5. So remember, this formula here is one that you're given, although it's quite a symmetrical thing, so you may well learn it, but don't rely on your memory. If you're not sure, always look it up in your formula sheets. Sometimes we might be asked to look at something which is algebraic in nature. So here we've got two vectors where we formed the cross product and we're given the answer. Well, if we want to work out k, we could either use the first element there or the third element in the table, because those will both involve k. So for example, taking the first element, then we can see from the table that will be 4 multiplied by k, and then minus 0, so we've got 1 multiplied by 0, and that must give us the value 12. So k is equal to 3. And you could check for yourselves that using the third element 6, that would also give you a value of 3. And there's the answer just to compare with your own working. So here the third element comes from line 1 multiplied by 2, so we've got 3 multiplied by 0, and then minus negative 2 multiplied by k, giving the plus 2k there. If you've already looked at the work on matrices, you may have realized that this formula for the cross product, it looks very similar to forming the determinant of a 3x3 matrix. And indeed, that gives us a way of writing the cross product. So the cross product can be written as this determinant here. So just to check through that, using the column to evaluate that, then this will be I multiplied by the determinant of A2, B2, A3, B3, and then minus J multiplied by the determinant of A1, B1, A3 and B3, and plus K, these are all vectors, sorry, I, J and K, K multiplied by the determinant A1, B1, A2, B2. And if you work out those determinants, you'll see that I is A2, B3 minus A3, B2, which is the top line of our cross product. This one here is A1, B3 minus A3, B1, but of course it's negative when we find the determinant, and that produces the middle line of the vector product. And finally, we get the bottom line from this determinant. So finding the determinant of this 3 by 3 matrix is made up of I, J, K, and then the columns for each of the vectors A and B in the cross product. So as an example of that then, if we're forming this cross product, then we could write that as being the determinant I, J, K, and then putting in the values 1, negative 3, 4, 3, 2, and negative 1. So that's equal to I, and then the determinant is the bottom part of this matrix here, so that we have the determinant, which will be 3 minus 8, then minus J, and negative 1 minus 12, and plus K, 2 and minus negative 9, so 2 plus 9. If you calculate those, we get minus 5I plus 13J plus 11K. Now what I'd like you to do is pause the video and see what happens if you multiply vectors in the other order. In other words, if this was A cross B, we're now calculating B cross A. And hopefully if you've done that correctly, then you'll have found that B cross A is minus of A cross B. So that's a general result. So B cross A will be equal to negative of A cross B. And if you remember with matrices, if you've done the work on matrices, then what we've done to work out B cross A is swapped the third and the second column, and that's always going to produce negative of the result. You may have a calculator that's capable of working with vectors, and if you do, then make sure that you know how to use your calculator to do that, so you can try working out the cross product of these two vectors. If not, then do this on paper and just pause and see in a second what the result is. Well, if you've done it correctly, you should have got the answer 21, minus 6, and minus 8. That completes this video on Introduction to Vector Products. In the next one, we'll be looking at how we use vector products.